Hey there. I want to show you something that has given me a lot of joy lately, which is rare for a technology, and that is nushell. It's a alternative shell, so similar to bash, set shell, fish, and so forth. But it's relatively recently developed, and it's done with a lot of like modern, nice ideas. Basically, think of all the things how we perceive programming to be different today than in the 70s, where everything was like string-based, ASCII-based, and think of like rich data types and stuff like that. And then what you could do if you could pass things between shell invocations in a structured form. That's basically what nushell is all about. And I really enjoy it, and so I wanted to give you a brief tour of it. Um, so maybe before we start, why would you like do that? What's interesting about the shell in the first place? So, of course, the shell in the end is just a place to like run particular programs, right? Like ls here in z shell and so forth. And then they give you output, and you can modify them, and they have flags and so forth. And then, of course, it's good if you can chain them together. So maybe you grab something, or do some other count lines, find whatever results, do something for each of the files you find, stuff like this. And then I think it's kind of nice if the sort of like progression towards more complex solutions is relatively gradual. And I think that this is something where Bash is like particularly not so great, or like even Setshell and others like that. Um, there's quite a bit of friction. Each of these commands works differently. If like they all pass the data in between them as text, and if you then want to switch over to writing scripts and so forth, I feel it's always quite a bit of a change in how to think about it. And I think that nushell does this in a nicer way. Let me show you how. Okay, so once you've installed nushell, I'll talk a bit more about that in the end. You invoke it with new, or you make it your default shell. I use it not yet as my default shell, but very often for all kinds of tasks. And by the way, one nice thing that you can recently do in VS Code is you can grab a terminal window here and drag it up, and then it's just like any other document window, and you can use it full screen or have it docked to some side window next to a document window and so forth. So here is nushell customized with Oh My Posh, and then let's have a look at how this works. So when I do ls here, on first glance, it seems pretty similar to normal ls, and maybe a bit nicer formatted, but that's it. But what is great about nushell is that it has rich data structures, and it passes data around as structured data. So in this case, what you're looking at is the output of vanilla ls, but then parsed into a structured form and output in a table. And the idea is that you then start doing standardized operations on these tables, right? So for example, if we want to say, I don't know, only the directories, then now we've filtered it, and where filters all kinds of tables, right? Similar, if we want to sort by something, modify it, for example, then we can see here, yeah, this is how you sort any table, right? But also, of course, it works for the output of ls. And then you just pipe these things together, and they come from people who are inspired by functional programming languages, modern functional programming languages with like a sort of like predictable vocabulary of operations. And this just makes for, I feel, a very nice experience of how to do these kinds of things, right? I mean, you can do all these things with vanilla ls and bash and so forth, but I feel that having these standardized operations that are like easy to memorize is a lot nicer than having to ask GPT-4 all the time of how to do things. Okay, so to take this a bit further, let's filter again, maybe on size. That's a bit bigger. And then one of the nice things, because this is structured data, is that we can output it to all sorts of other formats. For example, to JSON. So here we only have one row left. So it's an array now. Every row gets translated into a record. And then if we do this a bit smaller, oh really? Are they all so small? Oh. Wow, okay. There we go. You can see that this is very easy to do. You can also do YAML here, or TOML. TOML? Oh, okay, they don't have TOML as a target format. CSV anyhow. Okay, so this is pretty cool. And of course, there is also the reverse. So if you, let's quickly jump over to Grapher. If we do an open here of tsconfig, for example, then you will see that this will parse JSON just like we just wrote JSON. I'll come back to that in a second. Just want to show you two other things first. One of them is there's wrappers around all kinds of native programs, for example, also around PS that gives you the data in tabular form. And the nice thing is then you can just do all of the things that we just did, but on all the running processes. And I think this is pretty neat. If we look at sys, this gives you information about your system, all kinds of stuff, right, like memory and so forth. This is a bit overwhelming. What we see here is that it has no problem with nested structured data, so basically nested records, right? So the top level thing that we're looking at here is an object. It has a key named host. Inside of this is another object. It has a key named name, value is Ubuntu, and so forth. This is sometimes a bit hard to navigate if, like here, the data is quite big. So we can do stuff like, say, we want to only see the columns, or there is another command, which is what a lot of the commands do internally implicitly, which is table. This is basically the same output as before. But now we see that the output has been truncated, so it doesn't output everything. So table-e is what you get normally. If you invoke table explicitly, then you see the collapsed version where you can see only the keys and how big is the input. And if there's only a single primitive value, it will be output in here as well, which is kind of cute. Okay, cool. So this is how you work with structured data. And then you can also get certain pieces out of it with just a path, similar to how you would access it in a programming language. So for example, there is host, and we saw before that there is an OS version in there, and you can just reach in, right? And you can delete that, then you see the full part of what this object looks like. And again, we can always just put this into table if we only want to see the top level stuff and don't want to recursively print everything that is in there. Okay, cool. Let's go back to LS. One of the nice things is that they implemented LS in a way that can deal with recursive search. So ***, similar to how you probably know it as a syntax from many programming languages or configuration files and so forth, does a recursive search in all subdirectories, and then looks for anything that's called tsconfig, but of course we could also use star.config or whatever. This thing here gives us a lot of stuff, also inside node modules and so forth. So let me show you something else. Here I'm using now where a name doesn't match node modules. So this basically does a regex comparison. In this case, I'm just using node modules as a simple string to filter out the node modules directories. Okay, at this point, let me quickly show you what OpenTSConfig JSON does. So this, again, you can do for all kinds of structured data. But if you do this for the tsconfig at the top here, then we see that the textual representation that looks like this gets parsed into a rich data structure that is output as a nested table like this by default. And the cool thing now is that it's very easy to extend this and do stuff for each of the results of something, right? So if you do ls ** tsconfig, then we get all the results recursively somewhere in this directory, with where we now filter out the stuff that's inside node modules. And then with each, we can just invoke a closure, an anonymous function. It's what these curly brackets here do. And then the first thing is here that we say we want to give a name to the thing that we iterate over. We call it TS. And then we want to use open, the thing that we used above, to read the contents of data into structured data. We want to open the thing that at the file name that we just got passed in, and then we pipe it into get compiler options, and we say -i to ignore errors. We could also do this thing. to say, never mind if the thing is missing. And what we get now is every row is now one of those files that has been found with the ls search. And then for each of them, we parse the tsconfig JSON, and we put out a certain subkey compiler options of this file we take and put out and print it as a tabular form. This, I think, is quite powerful, and it's just nice and composes with all other sorts of things that you might want to operate on. So you can also do this for toml files and so forth, which is nice in the Python universe, and so forth. So this makes it really easy, right? Like this particular example, for instance, if you have a bunch of repositories and you want to see, hey, like, what's the module target for all these different projects? Are they the same, or are some of them common JS and some of them are ES modules? Then this is a really fast way to figure these things out. Okay, let's jump over to dataset. I want to show you something else. So in here we have a bunch of files, and some of them are SQLite databases that we create from our MySQL database. And lo and behold, I don't know, private DB. Lo and behold, we have an open command that can read SQLite files. And then we can just say schema, and then we can say table. And so this will open the SQLite file, print out the schema, and show us the results. So now we see here that there is one top-level key called tables. Let's look into that. And again, let's not put out everything and just see what we would get here. These are the tables that we have in here. So let's look at the variables section. Table up, table again. Okay, columns. Let's look at the whole thing. Cool. So now we can see the SQLite schema for this file, and it's very easy to do this, right? Something really powerful that you can do is that nushell knows how to join stuff. This means that you can like open a JSON file, open an SQLite database, and then just join specific subsets of these two like divergent data pieces together and do something with it. Write it back to something or output it, or see the differences. I don't know. This is stuff that you would usually have to resort to a programming language immediately, right? Like that's not something that you'd be comfortable doing in Bash, I guess. But then it takes quite a bit longer, and having this in your terminal, like sit there, all this power, is, I think, really neat. You can also do queries, by the way. So now we just ask for the schema, but we can also say, for example, select count star. You can do whatever you want, right? Select star from variables, limit 3, and so forth, right? Yeah, maybe one thing that's useful in this particular case, right? If you see stuff that's truncated, like here, so there's more columns than we can easily fit into my terminal. One simple way is to just select one and then do transpose. Then we see the whole thing flipped around, the first row. Another thing that you can do is there is a command called explore, and this is then an interactive viewer of data, and you can also like zoom into values. If one of those cells would be structured data again, then we could like go in there and so forth. So also useful. Okay, that was Explorer. What else do I have for you? Yeah, you can do HTTP requests really easily. So if you just, for example, here I have a JSON file that we use for our data pages. If I just HTTP get this, then we get the whole thing printed out again. So if I just do table, as I said before, right now we don't have the recursive output of everything. We just see the first level. And if there's a simple value, we see the simple value. And if it's a nested structured data, then we just see an indicator that there would be more structured data here. Again, yes, you can do stuff with curl, but I think it's really powerful that all this structured data is at your fingertips in an easily understandable and processable way. what else can we do with this? So if we do this, then one of the things that's nice to do is we can get something out of here. So for example, we have a date range, and this seems to be a string with a minus in between. And one of the nice affordances that nushell gives you is a function called parse, which can, you give it a pattern description and say, hey, I'm looking for something, and then a dash, and then something else. And I want to call the first thing that you capture start, and the other thing that you capture end. And if you run this, then you now get structured data out of this captured value with a value start and end, right? So if we now we could just say, I now only want to get the start value, right? So you can combine things easily like this. Okay, now if you need help on anything, you can just ask for it, right? For example, there is a thing called query web that I'll show in a second. And what it does is it executes HTML or CSS selector queries basically against HTML content. And if we want to see how that works, then it tells you here. And there's also a thing called tutor, which walks you through the basics of how to use nushell. But now I want to show you query web real quick. And the thing that I want to show you here is fetch our page and life expectancy and get all the H2 headers. Voila, right? Again, I think this is really neat that so much power is available with so little typing and without having to ask GPT for how to do it in Bash. You will probably ask now, well, that's all nice, Daniel, but what do we do with stuff like gitlog, right? So nushell doesn't come with nice wrappers around gitlog. So what you just saw is now just text output again, right? Which, yeah, would be nice if we could easily combine that. If you look at the nushell documentation, by the way, nushell can be found at this URL, right? Should it be get? Okay, this part I didn't try, so this is what you get for doing things on the fly first. And then we could do query up again. But if you want to do stuff like use gitlog, and if you look at the nushell website, they have nice documentation that walks you through all the concepts. They have a good command reference, and then they have a cookbook, which gives you like certain recipes for how to do common tasks that aren't covered in the base manual. One of the things that we'll suggest for gitlog is that, yeah, you can use gitlog with pretty printing, right? Basically something like this. So if you want to write multi-line pipelines, then you just wrap it in parents, and then you can do comments at the end of the line, right? Like this works, whereas in Bash with the backslash it doesn't, which is nice for scripting. But basically you wrap the pipeline, and then you say gitlog, and then you say, well, I want to tell you how to output stuff with this specific syntax for gitlog, and then I tell you to use these vertical pipe operators, and then I want to split the text output into lines, so this makes it into a structured series of like line elements, but the entire line is still one string, but now we at least have a series or like a one column table of only string lines. And then we say, and now we want to split it into columns by looking for this particular whatever, like separation character or sequence. And here's the names of the columns, right? So this is basically what they tell you to do in the cookbook, which sure works. We can do that. But wouldn't it be nice if it would be easier to parse structured content for common command line operations? Lo and behold, there is a thing called JC. And the way that I want to show you how to use this is gitlog JC. So what this does is JC is a program that doesn't have anything to do with nushell. It's a Python written project that parses common command line tool output into JSON. And nushell has very good support for JSON. And so what we can do here is we can just say, well, let's just parse the JSON that we get from JC, right? And then we can say take one and transpose. So this is again the trick that I showed you before. If you just want to see what this will look like and not have to worry about long string values, right? So this is what one particular row will now look like. And if we now take this away, then we can now see that we get a nice tabular representation of all the Git commits in here. The cool thing about this is then once you're here again, you can then very easily do stuff like select only the author and do a unique so that you get only the distinct authors. This is, I think, like a lot quicker than a lot of the stuff that you could do with other ways of getting to that similar information, right? Like getting the distinct authors from Git is possible probably with Git alone, Git log, right, or something like this. But it's then very bespoke. It only works in one program, and this way it's a lot easier. By the way, if you want to do something similar with Docker, did I do that here? No, of course I didn't. Let me quickly. So Docker has a similar concept. And now this is again, I shouldn't do this. I'm just improvising. I think it worked like this. Nope. Ah, yeah. Docker PS. It's not called pretty. Okay, let me quickly have a look. What this looked like. So the reason why I'm having a bit of an issue here is that I'm in the Linux version of Windows. So my Windows system, Windows subsystem for Linux, and nushell exists for both Windows and Linux, and so I have nushell in both systems, but then they don't have the command history shared at the moment. But it's really cool that the same kind of system can be used for both Windows and macOS and Linux. Okay, so this is basically what I wanted, right? It's for Docker, they have a native way of encoding the output in JSON, which is cute. Every line is one JSON object, so it's not an array of JSON objects. It's a number of lines, and each one of them is a full JSON object. So if you want to do this, then basically it's something like this to operate on that, right? Now you have again the output of Docker PS parsed into rich data structure, and then you can just transpose this and so forth. Cool. All right. I think that was pretty much all I wanted to show you. There's other parsers for all kinds of tools. So if you just look up the JSON convert documentation, you will find lots more tools where they have output parsers for them, which broadens the scope. There's also, you can use nushell for scripting. I showed you a little bit of what it looks like with the parents and the multi-line pipe, but of course you can do functions and so forth, and it's a functional programming language that's typed, but very accessible and easy to write, so pretty cute. If you want to install this, the easiest thing on macOS is to brew install. I'm not sure if it's called new or nushell. And then you will also want to install Oh My Posh, which is the thing that gives you the cute little GitHub indicators and the time and whatever, and you can customize it and configure it all you want. Yeah, this is basically it. Oh yeah, maybe a bonus point. You can also, like on Linux, it's a bit trickier. You can set up brew on Linux, but with Ubuntu, but I always find it a bit, I don't know, not so nice. So on my Linux system, I just installed the Rust toolchain, which is very easy with Rust up. And then cargo install new basically does downloads and compiles the source. And then once you have the cargo toolchain installed, you can also install stuff like bat, which is a really nice replacement for cat that does syntax highlighting. And there's also brute, which is really nice to navigate directories. Last tip, if you fancy this kind of thing, nushell has an experimental module called Dataframe. And this one, I don't know if you get it with the brew install method. With Cargo, you can install it if you enable it with -- features equals Dataframe. And that then allows you to open parquet files and I think feather files. I'm not sure about that. And CSV files and so forth with Apache Arrow libraries, and then run operations efficiently on data frames like that. So if you have like tons of parquet files lying around, that's pretty convenient. I tried it on some of our parquet files, or on like one or two. Like this feature wasn't so interesting to me, but I tried it on one or two of our parquet files, and there was some issue with some uint8 not being available or so. So maybe there's some incompatibilities sometimes between these files and data frame libraries. But I think it's also a very interesting thing that, who knows, right? Could be really cool and useful for something. Okay, that's it. I hope you found this interesting. Let me know if you run into any issues. I really enjoyed this, and I hope you will too. Take care.